Hi and good morning to everyone. This is NV Ramcharan. Right now I am pursuing BTech third year. We are here to present our internship project, and name of our project is Automatic Washing Machine using PIC16F877A. This project was completed as part of our training under the guidance of mentor Guhapriya ma'am. Our team consists of 4 members and myself, Vasishta Ramcharan. I previously mentioned before, and my teammates are Sohail, Hussein and Narhari. In this presentation, we will take you through what we learned, the tools we used, the project objective, a live demo, and finally our conclusion. The tools we have used is going to explain by me. The project objective is going to explain by Sohel, and a live demo, and finally our live demo will be explained by Hussein, and finally conclusion will be explained by Narhari. Now let's go into the introduction. We have developed this washing machine simulation entirely in software by using C and C++ languages. Our goal was to model the actual behavior of a washing machine, including wash, rinse, spin and drain operations without using any physical components. And we have used the MPLAB IDE to write and test our C code and simulated the microcontroller behavior to mimic how an actual washing machine works using a PIC16F877A. This project helps us to understand how microcontrollers process using logic, timing and decision making, all through software simulation. And we have learned so many things, how washing machine runs in real life, but it is not possible, so we have seen it in a software. What we have learned about how we use C programming microcontroller and microcontroller basics. What is PIC16F877A chip, LED, DKP board. DKP board means digital keypad board, MPLAB, IDE and simulation tools. Now let's go into it deeply. C means we have learned how to write code in a C program for microcontroller based application. It helps us to understand control software using code like turning LEDs on and off using logic. Now next is microcontroller basics. We understand the concept of a microcontroller. MC is a small chip that acts like a mini computer. It takes input and processes them and gives output to controller device. It is used in the embedded systems also, because due to this only it runs the washing machine. This is the main component. PIC16F877A is the main component in the washing machine. Due to this, it is also runs. This is a microcontroller. We have used it has 40 pins. Can be programmed in C and is widely used for learning embedded systems. It supports digital input timers and serial communication. Next is LED. We have learned how to connect LEDs to the microcontroller and control them by writing C programs. This taught us about GPIO pins and how to turn device on or off using code. DKP means digital keypads. This is also development board that helps us to easily connect the microcontroller to components like LEDs. It has all the basic setup needed for testing and running our project. Next is MPLAB IDE and simulation tool, which is a simulation tool used to run the washing machine. We used MPLAB IDE to write and compile and upload our C program into PIC16F8. It's the official tool by Microchip. Now next, my friend Soel continues the rest.
Hi again. I am Sohel from SRM University AP. I have just completed my second year in BTech Electronics and Communication Engineering. In this part of the project presentation, I will be explaining the objective of our project along with the tools, peripherals, and basic requirements we used for building the system. So let's start with the objective of our project, which is to design a mini automatic washing machine system using the PIC16F877A microcontroller. The idea behind this project is to automate the basic washing machine functions, such as washing, rising, and spinning using embedded programming and simulation. The system is fully controlled by a microcontroller. It receives input from user through buttons, for example, to start or pause the process. The process timing and status are displayed on a 16 cross 2 LCD screen. What makes this setup interesting is the use of relay to control real-time hardware like motors and heaters. We simulate the entire design using PICSIMPAB, which allowed us to test everything virtually. With this design, we get a clear understanding how embedded systems control real-world machines and how each component communicates inside the system. Moving on, the, moving on to the tools and requirements that we used. To build and simulate this project, we used three main software tools. So the first one is PICSIMPAB, which gives a real-time simulation of our washing machine model. And the second one is MPLAB IDE, which is where we wrote and compiled our code. And the last one is XC8 compiler to convert our C language program into a machine-readable format for the PIC microcontroller. As for the requirements, we needed a 5V 5-volt regulated power supply for the microcontroller, an external crystal oscillator to maintain accurate timing, and basic components like resistor, jumper, and connectors. These are very essential when building any embedded system. Now let's talk about the peripherals that we have used in this design. At the center of the system is the PIC16F877A, which is an 8-bit microcontroller from Microchip. To show what's happening, we used a 16 cross 2 LCD display where we can see the current operation like such as wash or pause, rising, and etc. And also a countdown timer uh, which really helps the user to understand. The keypad allows the user to start or stop the washing machine process whenever the user wants. We used relay modules to control the motor and heater. These relays act like switches that the microcontroller can turn on or off. The LM35 sensor is used to sense water temperature just like in a real washing machine. The DC motor simulates the rotation of the drum. The components such as like the fan, heater, and apron are used to simulate more realistic washing machine behavior inside PICSIMPAB. All these peripherals are virtually wired and tested in the simulation, allowing us to analyze how they interact in real time. So that was a quick but detailed explanation of the project objective, tools, and the components that we used in our automatic washing machine project. Thank you for watching this part of the presentation. I hope you understand whatever I have explained.
Hey everyone, my name is Sheikh Mohammed Hussain. I'm studying ECE third year at SRM University AP. Now I'm explaining about prior demo of our automatic washing machine system, which we designed using the PIC16F877A microcontroller. This entire project was simulated using PICSIMPAB, allowing us to verify how each component would work in real-world scenarios without needing hardware. First, we programmed the system in C language using MPLAB IDE and compiled it using XA compiler. Once the program was uploaded to the virtual microcontroller in the simulator, we could start testing the operation of each part. Our washing machine operates in stages. First, the wash mode. The system starts and an LED or output indicates washing process with delays to mimic real-time operation. Next is transit to rinse mode using program logic to switch stages with an indicator showing it's active. After rinsing, it enters spin mode to simulate drying, displaying the status via LEDs on or screen messages and and drain mode. It optional. We added a drain mode to make the simulation more realistic. Draining water after spinning. The program uses delays to manage timing between stages, flash to variables or to track which stage is currently running, and and if a statement to manage timing and transitions with the outputs shown in through simulated LEDs or simulated screen. And the project provided insights into how embedded systems control appliance using programming logic, closely mimicking real washing machine operation. Next, move on to live demo of our project output. Here, this is PICSIMPAB PIC16F877A, the board. Here there are some components like PIC16F877A microcontroller. It is a reset button. It is power on power off button, and there are some switches, 7 switches, and LEDs. There is a LEDs. It is a fan. This is a buzzer sound. It is a buzzer switch. This is, and it is a 16 into 4 display. Now I am explaining the step-by-step working of the system, how it will behave in the simulation. First, I load the compiled hex file into the microcontroller PICSIMPAB through making. Here, this contain all the logic of the washing machine in the embedded C. Initially, the LCD displays the machine. Press key 5 to power on washing machine. When I press key 5, the display shows powering on washing machine, and shortly after the available washing programs appear. Here there is a this is a washing program, and there are some options: daily wash, heavy wash, dedicated, and white stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store, and again it come daily, heavy, light. Why I use switch 4 to scroll these options. When I want to select a program, for example, I select a heavy, I long press switch 4. The system select the highlighted program and proceed to the next step. Next step, it shows water level. The LCD shows water level options like auto, low, medium, high, max, and auto, low. Again, I scroll using switch 4 and select desired level. For example, I select auto by long pressing the same switch. Once selected, the LCD shows press the switch 5 for starting, switch 6 for stop. If I switch 5 press, the system is started. It shows followed by estimation time. The next screen shows function was time. It automatically start. It switch 5 for start, switch 6 for pause. If I press switch it, the operation pauses and the time stop counting. See, see, the automatic time is stopping and fan is also stopped. If I press switch 5, again the program resumes from pause time and maintain continuity. See, again the time is continuity. Once program is completed, the LCD display program completed. Please remove clauses and it gives buzzer sound for 2 seconds indicating the end of the washing cycle. If I press switch 0, it gives door is open. Please door close door and also give buzzer sound also. See, the program is completed. Remove clauses and buzzer also ringing. Automatic and it automatically shows again washing program like heavy, dedicates, white, stain and also this is the complete our project washing machine program.
Good morning everyone, I am Narahari and I would like to conclude our project presentation on the automatic washing machine simulation using the PIC16F877A microcontroller. Through this project, our main goal was to stimulate the core operations of a real washing machine, including washing, rinsing, spinning, and drying, using embedded C programming and the PIC16F877A microcontroller. Though we worked in a simulated environment without actual hardware, we successfully implemented and tested the logic that controls each stage of the washing machine process. We used MPLAB IDE as our development tool, which helped us write, compile, and stimulate the behavior of our program effectively. The entire logic was written in C language, which not only improved our programming skills but also gave us practical exposure to embedded systems concepts such as timers, state machines, and input output control. The project really helped us understand how software and hardware can work together in a real world applications. It shows us how automation works behind the scenes and how microcontrollers play a major role in controlling devices like washing machines. One of our best parts of this project was realizing how each operation from filling water to the spinning the drum can be managed by precise logical conditions and timing. Although we haven't connected real sensors or motors yet, the simulations allowed us to visualize and test our system's behavior. In the future, we plan to extend this project by adding features like LCD displays, water level sensors, motor drivers, and many more, bringing it closer to a working hardware prototype. To sum up, this project gave us the confidence to work with embedded systems, develop real time logic, and troubleshoot in a simulated environment. It was a great learning experience, and we are proud of what we achieved through this effort. Thank you all for watching and listening to our presentation.
For watching this presentation. We are truly grateful to the Emertex team for guiding us throughout this internship, especially in explaining the fundamentals and practical applications of embedded systems. This project gave us hands-on opportunity to apply what we have learnt from microcontroller programming to real-time system simulation. It helped us understand how embedded system plays a crucial role in automatic in daily life applications like washing machine. Once again, thank you to Emertex and to everyone who has supported and encouraged us during this learning journey.